Assalamu alaikum student. I hope you will be fine and doing well, and you will be preparing your exams. Stay blessed at your home. Stay safe. We are we are dealing with a new chapter today. We will study the electrostatic energy and its subtopics. And the subtopic will include potential energy of a group of point charges. First of all, we will see what is electrostatic energy. We will see in the form of work done for the charges. When the mechanical behavior of an electrical system is to be studied, it may prove advantageous to use energy methods. In our previous classes, we have studied many mechanisms of energy dealing with mechanical work done, electrical energy, and sound energy, and so on. There are different types of energies. So, whenever mechanical behavior of an electrical system is studied, we will have to use some advantageous method to find out the total work done for a charge to bring it from one place to another place. In general, the energy of a system of charges, just like that of any other mechanical system, may be divided into its potential and kinetic contributions. Means when we want to discuss the energy of the charges, like any other mechanical system, we divide it into two categories. One is potential energy, and the second one is kinetic energy. And we know that kinetic energy is used whenever the motion of a particle is involved in the system, and the potential energy is involved when we discuss about the change the position of a particle, position of a substance from one place to another place against the height or like the gravity. Under static conditions, however, the entire energy of the charge system exists as potential energy. Whenever we deal with the charge system, a system of charges, then the entire energy will be potential energy. No kinetic energy will be involved over here. And in this chapter, we will particularly concern with the potential energy that arises from electrical interaction of the charges, the so-called electrostatic energy. So what will we see in this chapter? We will see the potential energy due to the interaction of the charges. Due to the change of the position of the charges from one point to another point, the energy involved in this process will be potential energy, and we will call it electrostatic energy. Then electrostatic energy U of a point charge is closely related to the electrostatic potential phi at the position of the point charge. So we have a very close relation between the potential and electrostatic energy and electrostatic potential of the point charge. And we know, we see that this relation. In fact, if Q is the magnitude of a particular point charge done by the force on the charge when it moves from position A to the position B will become work. It means that if we consider a charge of magnitude Q and we move it from position A to the position B, then the work will be done on the charge, and this work done will be equal to force multiplied by the displacement or the length that has been traveled by the charge from point A to point B. And the entire work done will be the integral from position A to the position B, so that the work done W will be equal to integral A to B F dot dl. And we know that F is equal to QE, and we put the value of F is equal to QE in this integral, and Q is the constant. That's why we take it out of the integral and we write the equation like that: Q integral A to B E dot dl. And we also know that E electric field is the potential gradient of the electrostatic potential phi. We have studied it in the chapter number 2 when we discussed the electrostatic potential in detail. We saw that the electric field is equal to minus del phi, means electric field as a potential gradient. So put the value over here, E is equal to minus del phi, then the equation will become work is equal to minus Q A to B del phi dot dl. That is equal to, if you solve this integral, it will become work done is equal to minus Q phi B minus phi A, minus Q into phi B minus phi A. Phi is what? Phi is the electrostatic potential. Phi B is the electrostatic potential at point B, and phi A is the electrostatic potential at position A. And we change the position from A to A, then the change in electrostatic potential will be delta phi. It will be written as minus Q into phi B minus phi A. So this will be the our work done while moving the charge from position A to position B. Therefore, here the force F has been assumed to be only the electric force QE at each point along the path. Electric force EF is equal to QE. We have studied it as an electrostatic force. Electric force F is equal to QE, although we know that electrostatic force is by Coulomb's law is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square, but over here we have considered the electric force instead of electrostatic force by the Coulomb's law. And under these conditions, the charged particle would accelerate. If it does not accelerate, the electric force must be balanced at each point by an equal and opposite force applied by some other agency. Ideally, charge should accelerate, but if you feel another force opposite to this force, it will decline its motion and there will be no acceleration, because we are studying the electrostatics. In electrostatic, there is no motion of the charge, so the force from an opposite agency will also be present over there. That's why there will be no acceleration, and the total work done in that scenario will be equal to zero, and the kinetic energy does not change. That is why the work done by this force, by the other force, is equal to W is equal to Q into phi. We know that we can see over here that the work done by the another agency will be equal to, in the opposite sense, W is equal to Q into phi B minus phi A. So this result is equal to the increase in the electrostatic energy of the charge over the path interval A to B. Means this work done is stored as the electrostatic energy of the system when it moves from the path interval from A to B. So this was basically the concept of the electrostatic energy. Up till now, if you have any question, you can ask me, you can write over here. But later on, you can also ask the questions about this topic. Thank you very much for the lecture. Up till now, we will start shortly the next lecture. Thank you.